later on. I'm now streaming live and I'm recording, so I'll start briefly again to explain what I'm doing here. Since I was 8, I've always enjoyed coding. I've always found it very relaxing to concentrate on a tiny, narrow world rather than the scary, complicated reality around us. And I've also enjoyed the opportunity of screwing things up, but then being able to hit undo, and it's always been just very very calming for me. And I've recently started watching a lot of other people coding via one of these streaming coding shows like this, and I found that almost as calming, not quite, which is why I'm actually doing it myself rather than just watching someone else as I have been doing for the last few weeks. So what I'm going to do is play around with some new projects. I really enjoy exercising my brain by trying to wrap it around some new, am I allowed to say paradigms, in coding? And that's what I'm going to do now. I'm actually going to explore a thing called Elm. Oops, there we go. Elm is a functional programming language that's designed to work in a browser. It compiles to JavaScript, and it's weird. It's sort of like Haskell, if you ever played around with that. And Haskell is incredibly erudite. It was the product of a committee, an academic committee, but still manages to be an amazingly beautiful language. It's used to explore new areas of thought in programming. So it tends to kind of sprawl. It's almost like a huge pile of PhD projects. And because they're PhD projects, they don't tend to be the world's most practical libraries and experiments. But they do hang together, and they do explore these new environments. Elm is the daughter of Haskell in many ways, but it's deliberately attempting to be mainstream, and it's deliberately attempting to be something that people can use from the get-go to do very practical things, in particular web applications. It's been designed really to do those sort of single page HTML apps that I'm still not entirely confident is the way forward, but I do think that at least we have a chance to explain how to explore how to make those programs work well, and we get to explore some of the aspects of the areas that Haskell has been exploring for many years. So the syntax is Haskell-like. The platform is JavaScript, is the browser, and the end result is kind of fun. All right, so that's probably enough talking. Do chat at me. I'm suddenly have this slight sense. It's about 20 to 12 at night here, so I have this slight sense that I'm just talking into nothingness. So if you are on the chat page, which is Twitch TV/Code Therapy/chat, please just say hello. I'm gonna type in and say hello now. Yeah, cool. Oh look, I did a tilde symbol. That's kind of interesting. Okay, so let's get back to where I was. And also, if you have any questions about the environment that I'm using here, I've just sort of set it up for the first time, but it's based on actually a windowing manager written in Haskell called Xmonad, and a few additions to that. So we can play around with that, and I can show you little bits of my environment that I've set up to do this, because it's all informative. Okay, so let me explain what I was thinking of doing here with the Elm. So there are a lot of great sort of examples, including the classic of coding examples, the to-do app. Now, for those of you who know, I've got some psychological damage from to-do apps. I try to avoid any kind of productivity aids these days. Um, but you can see this is something that has a little bit of Elm code and is designed to do all of the classic kind of programs. Now, I don't really want to explore that kind of thing. I actually want to do something from scratch. So what I was thinking about doing is another app which is less on the productivity aid and more on the massive increase of your own personal IQ sort of eugenics projects. So this is a thing called Dual and Back. Now, Dual and Back is if you've ever gone to have your brain tested by a psychologist, and if you have, I hope they didn't lock you up at the end of it. But if you did, this is one of those kind of psychological, experimental psychology games they play. And what it is it's a mind game, not a mind game as in your ex-girlfriend is trying to mess with you, but a mind game as in the sense of trying to get you to do a puzzle which will improve your memory and improve in particular, your working memory, which is the 5 things that your brain will allow you to keep in high speed cache before you forget it. And the amount of working memory is often strongly linked to people's general intelligence. And one of the reasons why Dual went back is kind of interesting is it was a brain puzzle that appeared to indicate that if you did it a lot, you would actually increase your, that's my cat dashboard, you will increase your overall working memory. Dashboard's very good at like heckling whenever there are moments of scientific potential inconsistency with what I'm saying. So this came out from some studies in around about 2008. And since then, people haven't been sure whether it's really just training you to be better at Dual and Back, or whether it actually does improve your IQ or does improve your working memory. But in general, it seems to be a fair amount of information to indicate that playing around with this game does improve something, and at least keeps your brain alive. So what is it? Well, somebody very nicely actually did a sort of instructive video here, which I'm just going to play. Wow, I have like adverts in adverts here. That's sort of interesting. I wonder who's ending up getting paid for that. All right, so what we see here is, let me just turn up the volume a little bit for you. As you can see, 2 things going on here. I'll go back and play it again afterwards. There's somebody saying something, and then there's a little grid here with little blobs appearing in various different areas. And what you really have to do is match what you're seeing or hearing at this particular moment with what you've just saw and you've just heard. So you can't quite see here because YouTube is hiding it here, but you can see there's 2 letters here, A and L, and they say position match and sound match. And they're actually the letters on the keyboard. And the idea is when you see a position match, i.e. when you see this blob match something that you've previously seen in the same place, you hammer on the A key. And if you hear something that's similar to something that you've heard in the past, you hit the L key. So what are you trying to match? It's a bit like Snap or a game like that, but you're actually matching things back in time. Well, that kind of depends on what N is in Dual and Back. The simplest game is Dual 1 Back. And what Dual 1 Back is when this blob appears and then it appears again in the same position. And then you go, oh, it was there last time, so I'll hit A. Or you hear someone say Q, because they say it in this strange robotic way. And then they say it again. Q. And you go, oh my goodness, that's a sound match. And you hit L. So that's dual 1 and back. Dual 2 back is when you have to cast your mind back to what was being said one go before the last thing that was said. Okay, I'm going to play this back now because you'll kind of hear what I mean. So let's turn it up a bit. This poor guy is experimenting on himself.
S S Q R C C.
So there was a position match back then. So if we go back a wee bit, you'll see. So it went blah. And then it's like, it's a little confusing there because they were all 3 the same in the row. But basically the one go before this was also there. So that's a position match, and he should have hit the A key.
Q Q H Q.
So that was a sound match, right? Because you'll remember that 2 goes earlier, the guy said Q, lady said Q, even though the blob was here, and then I think they said H and went up here, and then Q again. And because those 2 Qs match, even though there was something in the middle, that's a sound match. In fact, there has to be something in the middle because that's what the dual 2 back thing is, right? It's 2 goes back behind. All right, so that's what dual M back is, and you'll realize that that's pretty hard actually, because you have to keep not only a sort of mental list of what you just heard, 2 goes back, but you also have to mental list of 2 different things. You have to keep a mental list of what you're seeing and what you're hearing. And sometimes those 2 things happen identically at the same time, right? There's something the sound was the same and that position was the same, and you hammer on both of them. And basically you lose points for missing them, and you maintain your points for spotting them. So dual M back can get a lot more difficult than dual 2 back. The usual, I think most people get to dual 3 back. I wouldn't say comfortably, but certainly feel like they're stretching their mind muscles. And allegedly people have managed to actually do dual 12 back, although I sort of imagine that actually requires like extra RAM packs stuffed into your ears or something. The idea is that the more that you practice, the better you get at this, and the more you do this, the more you develop extended working memory in everything else, from remembering the last 12 weddings that you're supposed to go to just being able to recollect where the keys are when you're leaving for work, something I'm not doing particularly well at the moment. Okay, so let me just go back and to where I was. Here we go. That's nice. Yes. Yes. That's interesting. Excuse me a moment. There. All right. You guys aren't hearing that all the time, are you? No. Okay, good. Actually, I'm just going to do a quick double check to make sure that everybody is where they should be right now. As you can see, I'm just really getting the hang of doing streaming right now. So let's see. Okay. All right. So you're seeing me okay. And you're hearing me okay. Okay. All right. So you're seeing me okay. Great. Okay. Just had to make doubly sure. I'll never ever do that again. Okay. All right. Let's get started. So I think there's a couple of things that we should begin with. The first is, how do you get started with Elm? And actually, it's pretty simple. I'm going to just go through very quickly the tutorial to install everything you need to do. I actually have things sort of roughly set up, but I think it's worth kind of going through this manually and seeing how the initial app works with Elm. So let's go to the main site. Let's go to the docs. Let's go, there's an guide. Okay, there's a lovely explanation. Core language. This is all very exciting. I'll just look for installing Elm. There we go. More interesting. There we go. I'm actually using Linux, so npm install Elm. I wonder if this is coming. I'm going to go and see. This is just telling me that I should use sudo on this. I'm not sure this is actually what you're supposed to have. I think I've already fallen at the first hurdle with npm because you're not really supposed to set this up, so it's root and by root. But those are the penalties of slightly misconfiguring stuff when I set all of this up. So we've installed Elm, so hopefully we'll have, like, yes, a bunch of cool Elm programs. And that's surprisingly it. Okay, then. So Elm has source files, as usual, and it has a little built-in development environment, so which will run a web browser and compile your Elm files so that you can read them in the browser, and they're compiled from Elm into actually pretty much pure JavaScript. The one thing that the Elm reactor, as it's called, doesn't have is easy ways of putting in CSS or other HTML, which isn't actually that limiting, as you'll see for the first few experiments you do. But after that, it does start getting a bit trickier. So you want to have a slightly more advanced way of doing it. And by the end of this, I think I'll be able to show you this slightly more advanced environment that we'll use for creating dual back. Okay, so let me just see if I just type Elm Reactor. Right, so it kicks up a little web browser. You can type localhost 1000, which is the web address it's got there, and it shows you a little file navigator. I don't have any files here, but if there were any Elm files there, they would let you run it. So let's just create a little demo Elm app here, and we're going to import our HTML, and I think we'll import a bunch of other stuff. Let me actually bring up the import app just to show you. I want to do something a little bit more exciting than Hello World, so let's do. This is kind of cool. This is actually an in-browser way of using Elm. So you can actually type Elm into this side, and it will compile it and then display it here, and that's available on the main Elm website. But I'm going to do this locally, at least for me. So you already see that this is pretty clearly a module importing system, very similar to a lot of languages. You have some code that's written by somebody else or is built into the language, and you're just pulling in what you need. Exposing means that the various bits from each of these imported modules are then brought in, and so you can refer to them without having to say, go look on this module. They're just there for the taking after this. Okay. I appear to not be able to spell. Actually, I'm not going to do a one click here. I'm just going to set you up with a beginner program. View equals view. So this what I'm typing in here is really the heart of a Elm program. Just make sure I haven't forgotten anything here. Bear in mind, I'm learning this as I go. I'm being incredibly authoritative about how Elm works, but really I only started learning this last week. So if you're thinking I'm going to be able to do more than just experiment with these things, you have another thought coming. So from my limited explanations, this is still the heart of an Elm program. And we have a few interesting things here. One is that Elm works like a lot of functional programs by not changing state or really storing state, but by passing state around. So everything ends up in one sort of place where the current state of the program is, and that's handed to the various other bits of the app. And really, at the heart of a beginner's program with Elm, what you have is three parts. One is all of that state, and that's called the model. And that's sort of a variable. It's got a bunch of things in it. Then you have a thing called the view, and the view generates HTML based on the model. Let me just go actually spell model right. So, done that. And then you have update, and update changes the model. And because the view depends on the model, when you change the model, the view also changes. So those are the kind of three working parts of the program. There's something else that you'll see that sort of goes through all of this, which is messages, and messages get sent around so that the update part of the program knows that it's time to change something. So, but before we delve that far into it, let's just do something that is basically, I know I said I wasn't going to do Hello World, but I think it's probably a good place to start, don't you? So what we're doing here is describing this view function. So what you're seeing here is what's called a record in Elm, and this is actually kind of a I don't really want to call them variables, but the contents of a type, the contents of a thing. I wonder what they call variables in functional languages. That's a really interesting question. But to give you an example, I mean, if I was to say Fred equals hello, and like we're pretty clear here that Fred is probably a string, and you would emphasize that in Elm by saying Fred : string. That defines Fred. It says Fred, when you see Fred, Fred really is going to be a string. And what we have here is us setting Fred to a value. Well, the various things that you could have, you can also have Fred be a number, and it could be 32, or Fred could be one of these, which is a record. And then you would have things like food equals blah, and of course hello, and Jim equals 23, so forth. And then you could refer to that by saying, oh, what's Fred.foo? And Fred.foo would be hello. So what you're really looking at here for this bit is a generated record which has 3 elements to it, and they're called model, view, and update, but they're actually being assigned to something else called view, something else called update, something called 0. We're going to define what this thing is here. The other thing to notice is that in a lot of computer languages you have functions called and you stick all the arguments of the function between 2 brackets like that. So in JavaScript you might have hello. Well, in Elm the equivalent would be like that. You don't have any brackets. And you'll see later that that comes in pretty useful. That's something that is descended from Haskell land. I'm just gonna hello 4 people, please say hello in the chat so I know that you're actually there and you're not just various versions of me, and that you can hear me. Perhaps you can't hear me and that's why you're being so silent. I'm just playing around now so I can see myself and oops, apologies, and the chat client. Okay, I think the way I can do this, just, oh, I know how to do it. Hold on. This is less interesting to you, but it's very interesting to me because I'm gradually learning how to, there we go, how to live stream. I'm going to put that over to that screen. Wow, I'm slightly cross-eyed. I do apologize. All right, now you don't care about this, but this means that I can see what I'm doing, and I can see anybody if anyone's chatting. Boo. Oh, no, I lost someone. That's kind of embarrassing. I imagine in the dog-eat-dog world of Twitch, this is something that you shouldn't concentrate on. It's like the number of people that are listening or watching you. Otherwise, you'll just go crazy with the competitiveness of it. All right. I'm gonna pause that so that you have some bandwidth, and then let's continue. All right. So where were we? All right. So we have this program. It's passing this record around. The record has 3 parts of it, and we've got to make these things match up. All right. And beginner program came from this mysterious thing called HTML app, and we have these other things called div and text. Well, the next thing is pretty fun and interesting. It is view. So view takes 1 argument. So in the same way as we didn't have brackets before, when you're defining a function, and view is by all stretches of the imagination a function, it takes an argument, and that argument is just stuffed here next to it without any other brackets. I have to call it model, and it's actually a bit confusing, so I'm gonna, just for the purposes of this, call it M. So this is, you're going into this view function, and now you have M, and M is the model, and we know that the model is what? 0. Absolutely. So view is getting handed this argument 0, which we're actually going to ignore because we're much more interested in doing a hello world style thing. So let's go hello world. What's going on here? Well, div is actually another function, because this is functional language. Gosh, we have functions crawling out of every orifice, and it takes 2 arguments. And these are the 2 arguments. They're covered in square brackets because they're actually, I think, lists. I think that's the right word to call them in Elm. They can have 0, 1, or many elements. And the first one is the attributes that you want to put into a div. So div, for those of you just catching up with the modern world of HTML, div is a paragraph divider in HTML, and you can stick some attributes in that. Like you can say, oh, I want to style this and make it the color red, or I want it to, I don't know what else you can make happen with divs, but you can sort of dress them in attributes. Oh, yeah. But we don't have anything so interesting for that. And then you stuff into a div. You can put other divs, or you could put in a table, or you could put in a blob that's a movie. Here, let me show you in. What should we show? Let's have a look. Oh, look, you can see all the things I'm doing. This is my old website, and this is brutalist HTML, but if you look at something in HTML here, I feel like this is one of these explanations where if you don't know what div is, this really isn't going to help you, is it? But we'll brutally carry on. So here we have some HTML. This is an li rather than div, because in the old days there weren't any divs. You just had to use what you could find around. And inside that, you can see a link. And in Elm, or at least in this way of generating HTML for Elm, you might do that by saying li, and then, oh, this is an a, and there's nothing inside the a, but this a has an href. I think this isn't quite the right syntax for it, but you sort of get to see what's going on here. So it's basically kind of replacing pointy brackets with a lot of spaces and square brackets, because that's how we roll in Elmland. And if that seems a little weird to you, don't worry, it gets a lot cooler. Okay, so what we have here is we've said, oh, thanks for handing us this model, but no matter what that model says, we're going to end up giving you a div with some text in it. Now, I think we're just gonna, we probably do have to do update and I think we just have to do update. So let's do update. Update takes 2 arguments. Why is it blue? That's always a dangerous sign. I see. It takes 2 updates, and it's a message and a model. So the messages are sort of how you send things around in Elm. You send little messages to the update function. I'm going to go back to the hello world because that'll be brutal. Well, that's too brutal. I don't want to be quite that amazing. Oh, look, here's something that shows that li function. Just showing off now, aren't they? I wonder what will happen if I just say update message model returns. It's just supposed to return the model, but we'll see, because now we're going to try and compile this. So what I'm assuming happens with update, and I could well be wrong, is update is saying, hey, I've got this message. It's probably telling me to change the model in some way. I would like the model updated, and I'm returning a new model. I'm not changing the model itself, because pretty much everything in Elm is immutable. When I say Fred equals foo, Fred stays foo forever. When I'm saying up here that these things are equal to 0 or whatever, they stay equal to 0. They don't go anywhere else. So how do things change? Well, we'll see in a moment. But the first thing I want to do is see if we actually can get this running. All right. So now we go up. Confirms. So one of the things that's sort of awesome about Haskell, but it took me a long time to realize that it was awesome rather than the world's most frustrating thing in the world, is that when you run Haskell or another program that has is very strongly typed and does a lot of work with those types, then often it won't compile. If you make the slightest kind of error in the whole thing, it just goes, I can't touch this. I'm sorry. I have no idea what you're talking about. As opposed to JavaScript or Python or something like that, where the interpreter is very like, oh, I can kind of see what you're doing here. I mean, you haven't explicitly said it, but I know what you mean. So for me, in a lot of my experience with Haskell was just spending all my time going, why don't you compile? And the nice thing is once you do get it to compile, it works. And I mean, I don't mean it sort of works, and then about 20 minutes later you realize it's not doing anything like what you wanted to do. It just works. So basically, compiling is this huge filter which it catches almost all of the bugs that you would imagine, not just stuff about type safety, but like everything. And like once you can get through that filter, you actually end up discovering that everything else is pretty much in place. It's a bit like with the jigsaw puzzle, where if you can actually get the pieces to fit together, you're on a long way of knowing that you're actually building the whole thing correctly. Whereas I think JavaScript and Python and these other dynamically typed systems, very much like a jigsaw puzzle, which kind of lets you kind of like press the pieces in and like fit them, and they don't quite fit, but hey, who cares? And so you end up with a lot more problems down the line. This is my long and slow explanation as to why when I run this now, it's not going to work. So let's see. Oh my goodness, that I've never seen that happen. Isn't that interesting? That's my program. It looks like. Okay, so it works. Well, great. But I mean, notice it actually does work. So what we have here is a program that outputs hello world, and then kind of updates it, and yet doesn't, because we just returned the model itself. So that works. And if I do a view source on this, the HTML should be oh gosh, no, it's nowhere like what you want. Well, let me explain what's going here, right? It's compiled the program, and the program is somewhere else. I wonder where the program is. Oh look, it's probably being stuffed in here. So this is the downside of running compiling an Elm thing, right? Is that it's not HTML, right? It's a slightly mad JavaScript program. No one's going to be able to view source and see that and understand it. But if you look at the actual generated HTML, that does make some kind of a view. That seems relievingly sensible. You can see here that the div is there, and inside the div is some text. And actually, let's mess around with this now. So let's say viewer. Okay. Oh, I thought that would actually change it on the fly, but it's not. There we go. We can hit reload. And I can finally kind of explain, or at least discover, what I meant here. So put in style up here. So we put style, and then I think the way it works is we just give that an argument. We just say, oh, I think it's actually Aha, good. An error. The reason I'm excited that there's an error is not because I'm a masochist. It's because Elm these days has the world's freaking best errors. Oh, you know what? I think it's import HTML attributes. This isn't a particularly spectacular error, but it's just a taste of the awesomeness to come. So let's try this. This is my fly by the seat of my pants, not looking at the manual. But it looks like I've got somewhere here, right? So this is interesting. So this is what I mean about a really nice error message. So although I'm not quite sure why it doesn't show you the whole thing. Let's put it around. So here it's going, oh look, you've got something wrong here. It's saying the function style is actually expecting a list with 2 strings in it. But if you've given it just these 2 strings. That's great. I know exactly how to fix that, because all I need to do is put the square brackets, which is how you say a list. And then we'll do reload. And then look, the background color is set to red. If we have a look at the style, there we have it. Look, it's stuck in a little style thing into the div. And that's what I meant when I was saying that this stores the attributes. It's these little bits here. And look, it's done some nice stuff as well, like putting in a little semicolon there. So it knows what it's talking about, this program. Okay, what time is it? I've been talking for a fair amount of time, but I don't mind doing this a little bit longer if you don't mind either. Let me go over and see on my other screen whether you guys are rapidly shifting to me. Oh, hi. Good. I'm really glad. Hey, it's Kibitsu. Hi, Kibitsu. I know who you are. Oh, we don't get any timings on this. That's kind of sad. Hey, Wreck-It. I hope you're still with me. I apologize for not being... Oh, no, he's gone. He's gone. It's just me and you, Kibitsu. Well, I think hopefully I can explain the HTML. Was he just pouring scorn at the NTK HTML? Oh, well. Okay, let's go back to where we were. So we have this sort of interesting environment here. We know that it generates HTML, but you know, it's creating stack it. And I have just seen you reply, Kibitsu. So that's okay. I'm actually, just for those of you who are interested, I'm actually streaming this through a site called Watch People Code. Probably going to get thrown off Twitch for pointing out their competitors here. But Watch People Code is based on a Reddit group, and they will actually allow you to stream to their site, and there I am, look, and then stream on to other services like Twitch. So I'm a little just sort of playing around with Twitch at the moment. But I always like the idea that I am in control of my data, and this seems to be a pretty good way. These people are fairly friendly, and they let you fork your code off and stream it to other people like YouTube or any other Facebook Live. They all use the same protocols these days. So this seems to be a good way of doing that. I think the side effect of that, though, is that there is a delay, and that's okay, because I'm pretty slow as a human being anyway. I can just pretend it's all latency. Okay, so here we are with this little doohickey here, but if we wanted to generate static HTML, then there are really much easier ways of doing that. So what we actually want to demonstrate is something where we do the update. we send an update and the update changes the HTML in some way. So one of the things that we could do here is rather than have the text, we can actually represent something in the model. So you remember that view is being given an argument here that's the model, and that is all of the state of our program. And what is our state right now? Well, actually, we only have one thing here, which is 0. Actually, I'm going to make this a little bit more interesting. Call this hello world. So that's a state. That's it. That's the only thing we know in this crazy universe is that there's this text, hello world. And what we're going to do here is actually stick in that model. Again, I'm going to make this M so you don't get too confused about what we're talking about here. What we're talking about here is whatever's being given to view as an argument. And the way that the Elm architecture works is that view is always sent the current state of the model. Okay, so in an ideal world, great. So what we see here is it's generating this text based on what it thinks the model is. So we can change that. Go. I mean, I'm recompiling this, but because we've really established the model as a static bit of information, but nonetheless, it's still working out. Excuse me, I'm just going to make sure I can see people. Better way of, what I need is a better way of seeing you guys chat. Let's see. See, I have an excellent view of myself streaming. What I want is to try and, oh, you know what? I think I can just go to the chat page directly. Great. I can see who is around. Excellent. I'm sorry for my Twitch naivety here. This is the first time I've really used it. So, okay. So now, what were we going to do? Oh, right. So now we've created this static thing, but it's at least based on the model. It's at least based on something we're feeding it. But if programs only work by what we fed them at the beginning, we would live in a very dull and static world. So what we need is some way of changing this. Well, what can we feed in that would change, that we could use as a sort of cue to change a state? Well, in the example that we were looking at, the Elmsters were suggesting buttons, which is, a good old-fashioned way of doing this. So let's add button to our div. So we have our text, and then we're gonna put in a button. Dashboard. Dashboard is my cat. Click foo. I'm just gonna put foo here. You can see where I'm cribbing this. All right. I think that's all the square brackets that we need. So what we have here is a thing called click, which comes from another mysterious part of the Elm architecture. And on click takes this thing, sends something off, right? If you remember that we never put brackets around our arguments. On click is a function of some kind, and it sends something out. What could it be? Well, you're probably all cheating by looking over here, and it's pretty clear from over here that what we have is thing called message, which has something to do with what happens down on our click. Let me go into this a little bit. So what should we call this? Immanentize Eschaton. I will explain what that means in our pop culture moment shortly. So you'll notice that this is in a sort of shade of pink here, and that's because this is what's called in Elm a tag. Tags are kind of interesting, and they're one of those things that lives in the world of Haskell and other complicated type system environments, but they don't really exist anywhere else. Well, they do, but that's where they're at their most exciting. And what this really is saying here is that we're going to invent a new type of variable. I still don't really know what the word is for variables that don't vary, but and this is going to be like a string or an integer or a number or a float, the usual things that you stuff into variables. But this is going to be a brand new thing, and it's going to be very different. And in our case, we're slightly oddly creating a variable that can only take one value, and that value is immanentize Eschaton. And that's not a string value. It's not that it like hello world. It's just a thing. It can have one value. Well, variables that have one value are kind of not the world's most useful value. So let's create a variable that can have two values. So now we have a thing that says, well, look, this type message can either be immanentize Eschaton, or it can say nothing. And those are the two things it can do, and it can do nothing else. So in some senses, this is like a Boolean value, right? Boolean values can have true or false, but they can't have anything else. But in this case, we're only talking about these two things, and these two things don't have any meaning beyond this variable. But when we say one of these things in our code, the code knows that what we're talking about is this type. There's not going to be another sort of variable that has the value immanentize Eschaton. Actually, let's just call that there just to make that clear, right? Whenever we refer to this, we're clearly using this type. And that's actually kind of useful, and it's one of the features of both Haskell and this programming language at Elm that makes them a little less head-bustingly frustrating to use. If you've ever played around with C or C++ or other type languages, one of the things that's sort of really annoying about them is you have to spend the whole time going, oh, hello, Joshua. We're programming... I don't need to type. You can hear this. Hi, Joshua. So I'm exploring Twitch TV for the first time, and we're playing around with Elm, which is a programming language that works for browsers, and it's functional. I hope that makes sense. Join in. Hackle. Do what you will. So with a programming language like C or C++, you have to spend a lot of time actually manhandling the types, right? You have to spend a lot of time going, okay, I've got this variable C, and just so you know, this is an integer. And if you look in any kind of C or C++ code, a lot of the stuff at the beginning is like this sort of like drum roll business where you sit there going, and introducing the letter L, which will be an integer. And it's very annoying, frankly, because you have to explicitly tell the compiler a lot of things that just get in the way. And that's one of the things that makes Python and Ruby and other languages a huge relief, right? Because you can just sit there going, C equals hello world, and it works it all out for you. The nice thing with Elm and Haskell and these functional programming languages is that they have very complicated types, but the compiler spends a lot of time guessing on your behalf. And this is a good example of this, right? So when we type in goodbye cruel world here, right? The compiler automatically goes, okay, model, clearly a string. It's not going to be anything different, is it? I mean, that looks like a string to me. I may be a compiler that was born yesterday, but it's got the two apostrophes. That's a string. I'm going to mentally make a note that model is now a string. And because, unlike Python or Perl or these other languages, model and any other variable is not going to vary in this language, nothing changes. That lets it understand everything else. Anyway, this is a long way of saying that when Immanentize Eschaton appears here, Elm is just going to go, oh, that's totally type message. That is a thing that is a type message, and I'm going to tell onClick that this is a message, an MSG, and if onClick wasn't expecting an MSG, then I'm going to throw the world's biggest compiling tantrum error. So let's go back and see what happens when I hit. Okay, we get our little button. And when we hit mworld, nothing happens. But the reason why nothing happens is because we haven't set up anything to happen, right? What's happening now is when we click that, Immanentize Eschaton is a message, and it's going somewhere. Where could it go? Well, people who've read ahead will realize that it's going to oh, hey Joshua, what would make Elm better to use than Rails, HTML, CDs, JavaScript, etc.? It's a really good question. I don't think anything right now. Elm's a pretty young language. But what it is, if you've ever seen people getting extremely excited about Rust, one of the reasons people get excited about Rust is that it's pulling in all of these new ideas that aren't really in Rails or Python or JavaScript. Hi, dashboard. Excuse me. Just bring the cat into scope. Now the funny thing with Rust is that the reason why it's called Rust is because all of those ideas are actually like 30 years old. It just so happens that most of our programming languages don't include anything that happened after about 1975. And Haskell and Rust and Elm are an attempt to bring in these new ideas. So at the moment, you really wouldn't, I don't think you'd want to like actually go, oh, I've got a startup, I'm totally going to do this. But if you want to play around with these new ideas, it's a great way of doing that. And it's actually very deliberately attempting, the guy Evan who wrote it, is very deliberately trying to make these ideas mainstream. Why would you want to use these ideas? Because, and I trust me, don't trust me on this because I'm just exploring this myself. But the idea is that these approaches, functional programming language, immutability, message passing, and parallelism, get rid of a whole class of bugs that you might otherwise get in just crafting your own JavaScript or using a backend like Rails, or even constructing your own HTML. If you've ever constructed your own HTML, you'll know sometimes you forget to close a tag and all of this sort of stuff. And a lot of what Elm is doing is making sure that those kind of foolish errors either just can't happen, like they just don't need to worry about them anymore, or it warns you about them at the very earliest moment. It goes, I don't want to bother you, but I'm not actually going to do anything until you fix this. And that's frustrating to begin with because you just sit there like it's like having a compiler nag you all the time. But then you realize, God, like if I'd left that in, like someone who was actually using this software would discover it. Okay, I'm making a mental note that I don't need to talk quite as long as this for some of these things, but I'll try and compress. Still learning. Okay. Thank you, Joshua. Really good question. So we are back at immanentizing the Eschaton. So what we've done is we've set up a thing where when we click this, this message gets sent somewhere. And what it does is it gets sent to this function, update. So update takes two arguments. One is good old-fashioned modeler. I'm going to make it M again just to separate it from the model up there. And message, which I'm going to leave, actually, because otherwise it'll be another M and they'll be super confusing. You know what? Let's just do it the way God intended. Okay, so what we need to do here is we need to make what update returns change based on the message it's getting. And this is how you do this in Elm. So it has a thing called case, and case, yeah, Rails is pretty good. I mean, I think that Rails has this great kind of all batteries included feature to it. And Elm isn't quite there because people are only just beginning to create the software to do it. The two things I would say though is that it's really fun to join a community that is building that at the beginning, because you get the chance to play around. You get to not be a Rails user, you get to be an Elm foundation builder. And the other thing is that I think the biggest lesson that we learned from Rails was this idea of having these defaults, these useful defaults, and the people building Elm. God, I sound like I'm such a sort of Elm fanboy, but really I'm just kind of playing around with it. But anyway, they have the same idea, right? Like there's this thing called the Elm architecture, and that's like Rails is sort of, you do it this way, and this is the right way for using Rails, and really don't worry about doing something different. Just if you want to do that, use something that isn't Rails. Okay, so what we have is this function, I seem to remember, I may need to do some checking up here, where we say case message, is that the way around you would say? I think so. Let's try it. Case message of, don't necessarily have to trust me on this. No, I'm going to cheat. I can't bear it. I can't bear telling you something that isn't true. Let's see. Let's look at the syntax. Case. Oh yeah, I wasn't close. There we go. Case message of. Right, exactly. You that's exactly right, Joshua. You just use the defaults. It's really nice that way. I'm sort of constructing the defaults from scratch here with Elm, and you wouldn't normally do that, I don't think. I mean, you'll note that for those of you who've been listening since the beginning of this, that we talked a little bit about building an app. I'm planning on building a web page app, and we haven't got anywhere near that yet. But that's just because I'm sort of playing around with the little bits, the early little seeds, and so this is a bit like manually creating those files, which is educational, and you can tell it's educational because it takes slightly too long and you learn at slightly too slow a speed. All right, so case message of immanentize Eschaton. So what we're saying here is when message is immanentizing, is this value, what do we return? Now remember, what we're returning here is a new model. So this function here returns a model. So instead of returning hello world, let's make the default here hello world. Let's return goodbye cruel world. I don't know what SFML is. I know OpenGL, and I've wanted to get into it too, but I don't know what SFML is. What's that, Joshua? All right. So this is basically saying we're going to change the model into good pi cruel world when we get immanentized Eschaton. That's right. Okay, we got an error. Let's see what this error means. It says, this case does not have branches for all possibilities. Remember what I said about how when you use Elm, the compiler will help you to find things that you've missed. And what it's saying here is, well, you've dealt with the situation where message is immanentize Eschaton, but what about when it's no Eschaton? What about this other value that it can have? Now you see the advantage of having a variable that only takes two values, right? Now we can deal with all and only all of the values that we're handling here. That means that there's not going to be no scenario where message comes into this function and this function doesn't know what to do. And that's great because you know that there are many times in programming languages where a function gets thrown a value and it's not the value that the function was expecting, and the function breaks in very spectacular and not entirely entertaining ways. So what we do here is we write all of the other examples. And simple fast multimedia library. Is that like STL? I know STL, and that's pretty cool. But I don't know simple fast multimedia library. All right, Joshua, your quiz is, what does immanentizing the Eschaton mean? What am I talking about in this? And you can Google, but I fear that I might lose you for another 10 years if you Google it, or you can guess and I will explain it to you. Maybe do like 3 guesses as to what it might mean. Okay, so now Eschaton is, let's bring it back to hello world. All right, let's try that. Okay, so now we click the end world. It changes, and it doesn't change again because we've fixed that, but we can add another button here pretty easily that says no Eschaton. I think I need to get rid of some of these square brackets. Well, let's hit reload and see if it tells me. Yeah, it's going. It's not the world's best messages, but it's pretty close. So here we go. End world, restart world. And notice that it compiled, and as soon as it compiled, it worked. So immanentizing the Eschaton is actually a thing from a book called Illuminatus, which is one of the inspirations for a lot of like early geeks in the 1970s. It was written in 1976 by an ex-Playboy magazine editor, actually 2 Playboy magazine editors, called Robert Anton Wilson and Robert Shear. And the idea of Illuminatus was that there was a secret conspiracy that ran, actually there was like dozens of conspiracies that were controlling the world. And they ranged from the Dalai Lama, who wasn't the Buddhist Dalai Lama, which was actually a priest who lived underneath the Dealey Plaza. So it was the Dealey Lama. Dealey Plaza was where JFK was assassinated. And the Bavarian Illuminati were another conspiracy. They were a set of German freethinkers from the 18th century who were cruelly repressed by the post-revolutionary Europeans. And also the Discordians, who were a set of people who worshipped the god goddess of discord, Eris. So in the science fiction novel, the idea is that the Bavarian Illuminati were seeking to create the end of the world. And they did this by, the technical religious term for this is immanentizing, i.e. making more imminent, the Eschaton. And the Eschaton is the name for the end of the world. So when I end the world here, I'm immanentizing the Eschaton. The reason why I'm explaining all this is one of these books that would kick around the early geek community and influenced a lot of people. If you ever search for Discordianism, you'll find that actually it's buried in a lot of software. You can, for instance, there's a program called D-Date. Let's do it. D-Date, the Discordian calendar. So this is if you have a Linux computer, which I do. Do I have D-Date built in? No, but I can install it. Here we go. If I go D-Date, it will tell me in the Discordian calendar it's to prickle the 38th day of confusion in Yold 3182. So this Discordianism is scattered throughout the technical community. And in fact, even though it was a book that was just sort of invented as with these sort of jokes, people took great delight in actually creating the conspiracies that were mentioned in the book. So in the book, the reason why they picked the Bavarian Illuminati is because there were actually a lot of quite paranoid Americans who did really think that they were a secret bunch of Germans from the 18th century who were controlling the world. And they were trying to mess with their heads by going, yes, it's absolutely true. Except that there were some other people called these Discordians. And of course, as soon as all these young geeks read this, they went, okay, let's set up our conspiracy and we'll be the Discordian conspiracy. So let me give you just a couple of things to show you how far the Discordians go. If you go to the Chaos Computer Club, so Chaos Computer Club is one of the oldest hacking communities in the world. And the reason they're called the Chaos Computer Club is because of the influence of Discordianism. And if you ever want to go to a really good event, you should go to the Chaos Computer Congress I think it's in Frankfurt these days. It's huge. It's really exciting. It happens after December 27th, 30th, so the flights are pretty cheap. And when you get there, you will see stuff like this and these big images, and all of these images and all of the conceits of the Chaos Computer Club is that this is a secret meeting of Discordians, and it's all written in this Discordian style. So that is Immanentizing the Eschaton. That is my little slice of geek culture. Joshua, thank you for listening. Windows is awesome. Macs are great. And I totally encourage you to also play around with Linux because it's totally free. And you get to find out what the Discordian date is. And play around with Elm. I think what next time I'm going to do is actually get into the meat of the dual-end back program. Perhaps we'll start off continuing with where we are with our little main app, and once we've explained a little bit more about the structure, we'll start constructing a structure for dual-end back. So thanks for listening. It was really enjoyable. Thank you for being my guide to how to do a Twitch stream. I've really enjoyed it, and I think I might do it again. All right, now I have to work out how to turn this off. Oh, and if you have any feedback of any sort at all, just write me an email. I'm going to put my email address in the chat. And it's email me feedback at danny@spot.com. and I'll just put it here too. Email me feedback at speciday@special.com. And tell me how the sound was. Tell me, should I have a little music in the background? It's kind of maybe a bit distracting to have like little noises and stuff. And any suggestions you have. I'm a complete newbie when it comes to doing this, and I bet you guys have seen far more Twitch TV than I have. All right, I'm going to try and work out how to turn this off now. Thanks, everybody. Thanks, Joshua. Joshua, you're 12. That's awesome. Yeah, start playing around with this stuff. You know that they have a thing called a playground thing for iPads now for Swift, so you can actually develop some iOS apps on the iPad. I wonder if it's also on the iPhone. But yeah, if keep saving for a Mac and keep enjoying playing around programming, and yeah, play around with Linux because it's free, so you don't have to save up for Christmas. All right, I'm going to stop streaming and stop recording. Thanks very much, everyone. Have a great Independence Day weekend.